Hey, Physics 11 kids. I'm going to do a little description of the lab that we're going to do coming up this week, Monday and Tuesday. It's two parts, and so you see these two problems that we have been trying to solve, the over the pulley and then one mass on the table. We're going to do those for real, in real life. So I'll show you on your desk, you can use a ring stand and a clamp to hang a pulley, and you're going to hang two things over the clamp. These two masses can be anything. It can be your calculator and a shoe or whatever you want, as long as they're like not too different and not too close so that it doesn't move. It has to move and accelerate. You're gonna have to weigh both things. And then here's how we would do the problem. We'd get the net force and we'd add those two gravity forces. Of course, if you're mathy, one of these is going to be negative. If you're real worldy, you would do this one minus that one. But either way, if I go through these calculations with variables, the FG1 and FG2 are going to be just, that M2 mass times G and M1 mass times G. This one's going to be negative because it's pulling against, right? And you can actually factor that G out. And then this is just the sum of the masses because it's a total mass. And so you can enter in your numbers. Your numbers are going to be different than mine. This is my theoretical acceleration. It's theoretical because I haven't actually measured anything from this, but I can solve the problem and see what it would be. And then you could use this to find the tension force, but we're not going to do that today. I just want you to do this in real life. So, okay, so how do you actually measure the real acceleration? You take your cell phone and you video this with a meter stick in the background. You put that video on Logger Pro, and then you're gonna click on the graph on those labels and take the velocity in the y direction over time. And you're gonna get some slope, and the slope is blah, blah. I don't know what it's gonna be. And that blah, blah slope is equal to your acceleration in meters per second squared. This is your experimental acceleration. It's gonna be probably different than this because there's friction and weird things happen in reality, but hopefully they're similar. You're gonna take the difference between the two, turn it positive, that's what absolute value means, divide it by the theoretical one, and that's your percent error. So that's how far away your experimental time is from the theoretical time. You don't have to do any of this during the lab class. Really, all you need is to set this up, let it go, do the video, do the point in Logger Pro, and keep that graph and share that data with your group members. Okay, that's part one. Half of you are going to be doing this, while the other half are doing part two, and then we're going to switch halfway through class. Part two is the table problem. We're going to use the air track for that because it has no friction, or very little friction. You're going to have a rider, and you're going to have 2 or 3 masses that we're going to keep on this the whole time, but we're going to change how much is hanging. We're going to try to make it so that you have 150 grams hanging at some point, because we might want to compare that data later. So you might do 50 hanging and then 100 and then 150, or you might do 100 grams hanging and then 150 and then 200, or you might do 150 grams hanging first and then do 300 and 400. But your total mass should stay the same. So whatever masses are not hanging, you're going to hang them off the rider, hopefully in a way that doesn't cause too much friction. When you let this go, this is going to go down and the rider's going to go forward. And we're going to use our photogate to calculate a theoretical acceleration. So the photogate, remember, it just measures how much time this beam is broken. So you got to measure the length. I called it L. Measure the length of that card. Divide that by the time in your photogate, and you're going to get the final velocity. That's the velocity as the rider's going through the photogate. Now the rider goes a distance d in that time it's accelerating. So we can use this second formula, solve it for A. That's going to give us our experimental acceleration. Even though we're using a formula for this, we're getting this VF from and the d from measured quantities in our experiment. So this is experimental. You can solve this problem as we've been doing to get the theoretical and compare that as well. We're going to take this one a little bit further. We're going to do this 3 times, each with different hanging masses, but always the same mass. So you don't have to have a total of 200, but try to get one so that 150 grams is hanging at some point, at one of the 3. Okay, and then you're probably asking, okay, we are in a hurry. What do I need out of this part 2? Well, this is what you need. You really just need your total mass. So you're going to have to weigh the rider. You're going to need 3 hanging masses. So you can calculate the F net of the system. Just take this mass and multiply by 9.8. You're going to got to remember to measure the length of the card on the rider. And then you're going to have 3 photogate times. If you can get that stuff done using your AirTrack, you're good for the lab class. That's really all you need. If you have all of this done, you can put that in a spreadsheet or a note or whatever you want. When you're finished this, you're going to graph, and you can use Desmos or Logger-Pro or whatever. And this is what I want you to graph. You're gonna have done this 3 times. And so this graph is gonna have 3 points. You're gonna have 3 sets of data with FNet and your A that you got, your theoretical A. Or sorry, your experimental acceleration. So you're gonna look, is this linear? Can you find the slope? What does the slope of this graph mean? And what's the relationship of this? So what's the formula you get out of the graph using y equals mx plus b? Of course, you're gonna have a different y and x and m and b. You can do these graphs on Desmos or Logger-Pro or whatever you're comfortable with. This is not a formal lab, so you have to have a title, but you don't need purpose, procedure, all that stuff. So we're gonna do part 1, half of you, and the other half will be doing part 2. You'll be 4 groups doing this, 4 groups doing this, and then we'll flip halfway through class and you'll switch sides of the classroom. And as long as you get this data from part 2, and as long as you get your video from part 1, you're good. And then I'm gonna give you a free class, the class after, to do, to work on the lab. And then I'll tell you what's coming up later in the next video.